If f of x equal to ax square plus bx plus c equal to 0 is a quadratic equation, then the quadratic equation whose roots are reciprocals of the roots of f of x equal to 0, reciprocals of f of x equal to 0, that is f of 1 by x equal to 0. And also if the roots are greater by m, okay, let me describe how it was happening. Let us suppose f of x equal to ax square plus bx plus c is a quadratic equation, and it has some roots alpha comma beta. And now we are going to create the roots of quadratic equation whose roots are 1 by alpha and 1 by beta. Okay. So here you can replace this x with alpha. Then the quadratic equation become a alpha square plus b alpha plus c. Okay. That means what we have done here, we are replacing that variable x with alpha, because alpha is the root of this quadratic expression. The same thing we have to perform here also. So what we are going to do is we are equating x equal to 1 by alpha to create the quadratic expression. So now x equal to 1 by alpha, that means alpha equal to how much? 1 by x. That means now this equation becomes, because alpha is also a root of this quadratic equation, it's satisfied by that. So now we are replacing x with 1 by x. So a of 1 by x square plus b of 1 by x plus c equal to 0. In other words, it is simply called as f of 1 by x equal to 0, whereas f of x is ax square plus bx plus c. Understood? Therefore, point is f of x equal to ax square plus bx plus c equal to 0 is a quadratic equation. The reciprocals of the roots of f of x equal to 0 is f of 1 by x equal to 0. Got it? Like this. Now, second point. If the roots are greater by m, then the equation is this one, f of x minus m equal to 0. Let us do this. Suppose we already know that alpha is a root of f of x equal to 0. Now, the new roots are, what are the new roots? Alpha plus m, comma beta plus m. Why? Why? Because the statement says, what the statement says? The statement says the new roots are greater by m of the roots of f of x equal to 0. So that's why the new roots become alpha plus m and beta plus m. Therefore, the same process we applied here also. So let us consider x equal to 1 of the root, equate it to 1 of the root. I am equating to this variable x to alpha plus m. Now it will be x minus m equal to alpha. Now we already know that if alpha is a root, then f of alpha equal to 0. So just replace it with x minus m. So f of x minus m equal to 0. That means if m was added to the already existing roots of alpha comma beta, the new equation consists in the place of x as x minus m. That means the new equation will be a of x minus m whole square plus b of x minus m plus c equal to 0. Is there any doubts in this concept? No? So the reciprocal equation was f of 1 by x equal to 0. If the roots are greater by m, the new equation is f of x minus m equal to 0. The same process is applied for the remaining points also. If the roots are smaller by m, that means alpha minus m and beta minus m are the roots, then the equation become f of x plus m equal to 0. And if the roots are multiplied by m, if the roots are multiplied by m, that means the new roots will be alpha m comma beta m. Then the equation will be, you have to divide that variable with m, because here we are multiplying. Here adding, so subtract here. And it was smaller, that means subtraction, and you should add here. So submultiples of m. Submultiples of m means, submultiple means division. Division like this. That means alpha, beta are the roots. Submultiple means alpha by m and beta by m are the new roots. Are the new roots of the equation. Then the equation becomes f of mx equal to 0. Numerically equal but opposite in sign. That means minus alpha and minus beta. Numerically equal but opposite in sign. That means the new roots are minus alpha minus beta. Then the equation will be f of minus x equal to 0. So using these concepts, the questions are as follows. Find the equation whose roots are reciprocals of these roots. So he said reciprocals, that what should we do? Just replace x with 1 by x. Look at here. Then we have the new equation whose roots are reciprocals of the existing quadratic equation. Next, find the equation whose roots are equal but opposite in sign. That means just change x with minus x like this. F of x equal to 0 and f of minus x equal to 0. That means numerically equal but opposite in sign. Okay. Find the equation whose roots are 3 times the roots. 3 times the roots means if this quadratic equation has alpha, beta or roots, the new roots has 3 times of these roots. That means 3 alpha and 3 beta. We have to create a quadratic equation. The new roots are, by taking these roots are as 3 alpha, 3 beta. So it was very simple. Just divide x with 3 and create f of x by 3. Look at here. So that is the new equation whose roots are 3 times the roots of the given quadratic equation. Next, find the equation whose roots are 1 by 4 times. That means it is called submultiple. So what should you do? Replace x with 4x. Look at here. This is the original equation and this was new equation. The difference is only replace x with 4x because we need 1 by 4 times of that roots. That's the new equation. Next question. The equation whose roots are greater by 2. Greater by 2 means you have to do reverse operation. That means replace x with x minus 2 in the given equation. You have the new equation according to this strategy. Next concept, common root. Common root and its condition. Okay. So two quadratic equations. For example, the new quadratic equations are as follows. A1x square plus b1x plus c1 equal to 0. And another quadratic equation, a2x square plus b2x plus c2 equal to 0. These quadratic equations, suppose if they have some common root, that means you should solve these two equations. So how to solve it? So solving is same as we do for solving of xy, double parameter. So take b1, you should start from the middle, b1. Next is c1. Next again a1. Write the coefficients. Next again b1. Next, except for the second equation, start from the middle. Write down the coefficient of x, b2. Next, write down the constant c2. Move to first. Write down the quotient of x square a2. And next, quotient of x is b2. Here, in traditional solving, we will write x, y, and constant. But here, you have to write x square, x, and 1. Why? Because here the variables are x square, x, and constant. That's why. So now, x square by b1 into c2 minus b2 into c1 is equals to x divided by c1 into a2 minus c2 into a1, which is equal to a1, which is equals to a1 b2 minus a2 b1. Now we will equate these two at first. Then we have x equal to, here x is a common root for the both quadratic equations. C1a2 minus C2a1 divided by a1b2 minus a2b1. And if you equate the first value and the last value, then x square equal to b1c2 minus b2c1 equal to 1 divided by a1b2 minus a2b1. Now remember this x value, because often we have to use this as a common root. Common root for both quadratic equation is C1a2 minus C2a1 by a1b2 minus a2b1. From this equation, move this denominator. Now it is x square equal to b1c2 minus b2c1 divided by a1b2 minus a2b1. Now what is x? Just replace here in this x square. Then the solution becomes C1a2 minus C2a1 divided by a1b2 minus a2b1 whole square is equals to b1c2 minus b2c1 divided by a1b2 minus a2b1. Look at the denominators. You can cancel that in one time. And one time, remember, one time left here in this left side denominator. Therefore, the condition for having common root is C1a2 minus C2a1 whole square equal to a1b2 minus a2b1 into b1c2 minus b2c1. This is the condition. This is the condition. This is the condition for having a common root. For having a common root, and the common root will be this one, C1a2 minus C2a1 divided by a1b2 minus a2b1 and this is the condition. So both we are using while solving the problems. You have to remember these two results from a common root concept. So the first thing, what is a common root? Common root means two quadratic equations having same root. Then it is called a common root for both. So generally the common root x will be in the form of c1a2 minus c2a1 by a1b2 minus a2b1. And for having that kind of common root, the condition is c1a2 minus c2a1. The same thing you should mention in two places. For common root and the common root condition. c1a2 minus c2a1 whole square equal to a1b2 minus a2b1, b1c2 minus b2c1. Next, case 1. What is case 1? Case 1 means if a1b2 minus a2b1 is equals to 0, then automatically c1a2 minus c2a1 is 0. Why like that? Because look at here, if a1b2 minus a2b1 is 0, a1b2 minus a2b1 is 0, then this denominator will be 0. That means the common root does not exist. Common root does not exist. If it was 0, do cross multiplication, automatically c1a2 minus c2a1 is also 0. And if you substitute here in this place for having common root condition, it also shows that c1a2 minus c2a1 is 0. In this case, what will happen is a1 by a2 equal to b1 by b2 equal to c1 by c2. In this situation, a1 by a2 equal b1 by b2 equal to c1 by c2. That means the two quadratic equations must be in proportion. The two quadratic equations, as we started this discussion in this part, a1 by a2 is same as b1 by b2 is same as c1 by c2. That means the coefficients of quadratic equation are in proportion. They do not have any common root. That is the thing we can learn from this result. And hence same roots has a that means both of these two equations have same roots, and hence these equations have a common root. If it was not equal to 0, then the denominator must not equal to 0. That means a common root exists. And the condition was, we know that already, that formula c1a2 minus c2, that is the common root if it was not 0. Now, some solved examples regarding on this concept. The first question, x square plus bx plus c equal to 0, x square plus cx plus b equal to 0. Here b not equal to c he mentioned. Have a common root, then show that b plus c plus 1 equal to 0. Let alpha be a common root. Then this alpha should satisfy both of this equation, because for both of the equation, this was the only unique root as a common root. So if you substitute in the first equation, it will be alpha square plus b alpha plus c equal to 0. From the second equation, just replace this x with alpha, then alpha square plus c alpha plus b equal to 0. And say that first equation and second equation, do 1 minus 2. If you do 1 minus 2, alpha square got cancelled. And alpha is a common factor, b minus c, and on the other hand is also b minus c. That means alpha equal to 1 is a common root. So if we already assumed that alpha is a common root, and we have the value that alpha is equal to 1. That means you can replace this alpha equal to 1 either in the first equation or in the second equation, because this alpha is a common root for both. Just replace x with 1. Therefore, you will get 1 plus b plus c equal to 0. If you do the replacing in the second equation, there also you got the same result, that b plus c plus 1 equal to 0. Second question. If x square minus 6x plus 5 equal to 0 and x square minus 3kx plus 35 equal to 0, have a common root, then find the value of k. So this was interesting problem. Here we will use the concept of having condition, having root condition. The root conditions are, the condition was C1A2. Remember the formula? C1A2 minus C2A1 whole square equal to A1B2 minus A2B1 into B1C2 minus B1C2 minus B2C1. And here, from the first equation, A1 equal to 1, B1 equal to minus 6, C1 is equal to 5. And from the second equation, A2 equal to 1, B2 equal to minus 3k, C2 equal to 35. Since they have, he said, they have common root, so we are using this formula. So C1A2 means 5 into 1, 5 minus C2A1. C2A1 means 35 ones are 35 whole square equal to A1B2. A1B2 means A1 is 1, B2 is minus 3k. So 1 into minus 3k, minus 3k. A2B1, A2 is 1, B1 is minus 6. So minus of minus plus 6 into B1C2. B1 is minus 6 and 35. How much is 35 sixes? 6 5 is 30. 3 in your mind. 6 3s are 18. 18 3, 21. 210. Minus B2C1. B2C1 is minus of minus plus. 5 3s are 15k. Therefore, from here, 5 minus 35 is minus 30 whole square, which is 900. And here, 3 is a common factor. You can move that 3 minus k plus 2. Here also, 5 is a common factor. 15 is a common factor because B1C2, 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 15, 5. Okay, you can take 15 as a common factor from here. Then k minus, how many 15s are 210? How many 15s are 210?
14.
14. 14 15s are 210. Yes, 14. Now we can cancel 3 table in 900, 300 times. 15 goes to 30 in 2 times, that means 20 times. So 20 equal to, just multiply minus k into k, minus k square, minus k into minus 14 plus 14k, 2 into k, 2k, 2 into minus 14 minus 28. You can move all the terms on the same side, k square, 15k, 12k, 14k, 2k, 16k, minus 16k, and minus 28, 28, 48 equal to 0. And this will be 48, 48, 12 fours. You can use 12 fours, 12 and 4, minus 12 and minus 4. Therefore, k equal to, you can change this sign. Plus 12 and plus 4. This is a shortcut. You can change the numbers, these numbers. That is the rules. So 12 and 4 are the required roots of this 12 and 4. Now, question number 3. Solve 2x power 4, x power 5, minus 12x square plus x plus 2. So this is called reciprocal equation. Later we will discuss about this in the next chapter. I will teach you in the next chapter. And this kind of equations also we will discuss in the theory of equations. And if you're interested, you can solve this equation. Take 3 power x is equal to 10. You can solve these equations also. Okay. This type. Look at this type. The shortcut was the numbers. Look at the numbers 3 and 5. Minus 3 minus 5, how much? Minus 8. 1 minus 1 and minus 7, how much? Minus 8. In that way only you have to consider the factors together. So we have to write side by side x minus 1 and x minus 7. Why we are writing like that? Why don't we take x minus 1 and x minus 3 together? Because the middle terms cannot be, okay, after multiplying, I will show you. By using this technique, we will solve this equation easily in a short time. So you have to decide which factors should be taken together and multiplied together. This process, remember this process. Look at the constants. Here it is minus 1 and you have to, this value is minus 7. You have to add those values. Minus 1 and minus 7 added, minus 8 will be the result. Similarly, minus 3 and minus 5 will be minus 8. In that way, they will be equal. So those two factors pairwise you have to take and multiply together. Then the equation will be easily solved. Okay, according to that technique, x minus 1 into x minus 7 are taken together and x minus 3, x minus 5 taken together. If you multiply these two bracket values, x minus 1 and x minus 7, you will have x square minus 8x plus 7. And if you multiply x minus 3 into x minus 5, you have the quadratic equation x square minus 8x plus 15, which is equal to 9. And look at the similarity of these two factors. X square minus 8x is a same term exists in the two factors. So what you do is take x square minus 8x as replace with y. Then the first factor become y plus 7. Second factor become y plus 15 and which was equal to 9. Now look at here where y is equal to x square minus 8x. Now again multiply these two numbers, y plus 7 into y plus 15. It will be y square plus 22y plus 96. And this 9 is also included in the solution. Now if you do factorizing, you have the roots minus 16 and minus 6. And we already know that y was not just y, it was x square minus 8x. Now again replace this y with x square minus 8x and solve, equate it to minus 16 one time and minus 6 to another time and solve for the solution. We will get the roots like this. Understood? Now this one. Root of x by x minus 3 plus root of x minus 3 by x equal to 5 by 2. This was very easy. Root of x divided by x plus, what was that? X divided by root of x minus 3 plus x minus 3 divided by x. And it was how much? It was 5 by 2. 5 by 2. Okay, do one thing. Look at these two numbers are same numbers but in reciprocal order. If you say this is t, then it will be automatically 1 by t equal to 5 by 2. Can you split this 5 by 2 into two numbers like the same pattern? Can I write like this? 2 plus 1 by 2. Am I right? 2 plus 1 by 2 is same as 5 by 2 now. So now equating on both of the sides, either t equal to 2 or t equal to 1 by 2. Am I correct? Right?
Yes,
What
sir.
is t? Actually, t was taken this value, right? Do whole square, remove that square. Now t was x by x minus 3 equal to 4. And in the other hand, it will be x by x minus 3 is equal to 1 by 4. Got it? Now do cross multiplication. X equal to 4x minus 12. And here 4x is equal to x minus 3. Therefore, 3x is equal to 12. Now x is equal to how much? 4. Now from this side, 3x is equal to minus 3. X is equal to minus 1. X is equal to minus 1 not valid. Why? Can you tell me why it was not valid? If you write x value as minus 1, look at this value, root x by
Imaginary.
x minus 3, is it valid or not? We have to cross check, okay, the gotten solution. Minus 1, minus 1, minus 3. Yes, it is valid. Yes. Root 1 by 4 minus minus got cancelled. Yes, it is valid. So both are solutions for this equation, minus 1 and minus 4. Plus 4. So plus 4 and minus 1 both are solutions here. In the same way, solve this equation also, x plus 1 by x whole square, x plus 1 by x whole square minus 3 by 2 of x minus 1 by x equal to 4. And try to solve this exercise 1.1 completely. Find the roots of the following quadratic equation. You know how to find, use the formula x equal minus b plus or minus root of b square minus 4ac by 2a. And look at the second question. Second question, it says, form a quadratic equation whose roots are. Take one of the value is alpha. 7 plus 2 root 5 is alpha. 7 minus 2 root 5 is beta. Okay. This one is alpha. P minus q by p plus q is alpha. Minus of p plus q by p minus q is beta. Take like that and form a quadratic expression. And you know these values. Just do it LCM. What is the LCM? Alpha into beta, and here in the numerator, alpha plus beta. You know that what is alpha plus beta? Minus b by a. And what is alpha into beta? C by a. So the value is minus b by c. Now here also do the same. Alpha square plus beta square divided by alpha square into beta square. Alpha plus square plus beta square is b square minus 2ac by a square divided by alpha square beta square is c by a whole square. A square cancel. Now the answer is b square minus 2ac by c square. In this way, solve the remaining questions. Try these questions. Try to complete this up to 4. Next, here in the fourth question, discuss the nature of the following quadratic equations. Just calculate the delta value. Discriminant b square minus 4ac. According to that, define how the roots are looking like. Okay. So up to 4, solve these questions and send me in WhatsApp. In the next class, we will discuss the remaining questions and answers. Okay. That's all for today. Yeah. Yes. Yes, Suhas. Any doubts?
Not me.
Dhanush. Do you have any doubts, Dhanush?
No doubts.
No doubts. Okay. Are you in the group?
Yes, sir.
Okay. Okay. Try these questions. Tomorrow we will meet in the same time, 3 o'clock. Bye-bye.